Hello, everybody. Before we start, I would like to say some words. I really appreciate being here. And I know that some of you were expecting a workshop from me about domain-driven design. I'm very sorry that I wasn't able to give that presentation for you because I was expecting to be arriving here at Krakow yesterday night, but my flight got delayed because of a thunderstorm in Amsterdam. So I just arrived like 1 hour ago. And so I thank the organizers also for changing the schedule for me to be able to present this session right now. And that's the words that I want to say. I'm so sorry for not being able to arrive earlier, but I couldn't control the weather. So, but anyway, it's a great pleasure for me to be here just to present this subject for you. But unfortunately, I hope to be able to come to Krakow another time to deliver the domain-driven design presentation with the workshop, which is a subject I've been studying for the past few years, and I think I might have some tips and some content that will be useful for you. But again, it will have to be in another opportunity. And I don't know, are we good to go? Yes? Well, I guess we are. So if it's recording now, good afternoon, everybody, again. I'm very pleased to be here in Krakow for the first time. Just in case you're wondering, there are not many Asians here in this part of the world. And I'm a Brazilian Japanese, and yes, I came straight from Brazil. So I took a long journey, maybe the longest one of all the speakers to be here today. And today I'm going to be presenting for you a migrating to microservice databases from relational monolith to distributed data. My name is Edson Yanaga, and I'm a Director of Developer Experience at Red Hat. My Twitter handle is @Yanaga, just in case you want to follow me. I talk a lot about DevOps, microservices, Java, domain-driven design, software craftsmanship, and other subjects. I'm also a Java champion and a Microsoft MVP, and I know it looks like a kind of weird combination, but in the end, it just proves to us that the world has changed a lot. In fact, Microsoft granted me the MVP award because I helped them to improve the Java support on their cloud computing platform, because I think in the Java world, we value very much open source, we value choice. And it is very important for us as Java developers to be able to have many different options for deploying our applications on cloud computing providers. That's why I helped them, and it has improved a lot since 3 years ago when I started this work. And just to give you a tip, I just released the book from O'Reilly, Migrating to Microservice Databases, which is the same subject of this talk. It is available as a free download on this URL, developers.redhat.com, promotions, Migrating to Microservice Database. But just in case you don't want to type all of this URL, you can just go to developers.redhat.com/books, and you have an index of all the books that Red Hat has published with O'Reilly, so my book is one of them. So you'll be able to have the free download. And just in case, if we have some questions, or maybe I can just give them away in the end, I have 4 hard copies of the book for you. So some of you might be able to get a hard copy. So this will be a very intense talk. I have a lot of content to be sharing with you in like only 50 minutes. So forgive me if I speak too fast, but just because we have a lot of content to be covering, and I want to present you a very nice demo in the end on how can you integrate these microservices databases using a technology called Debezium. So let's start. I always like to start my sessions with this sentence, which is not from me, but from Forbes, which says that now every company is a software company. I like to say that you don't work for a bank, you work for a software company. You don't work for an industry, you work for a software company, because software is changing the world. And I used to be one of these people that thought that economy had everything to do about money. But then after studying a bit of economics, and particularly behavioral economics, I just realized that economics has nothing to do about money, but has everything to do about people. Because economics study how people interact with each other into a system, how they change this system from one state to another state. And some of the motivations that people have to change this state from one point to the other can be like love, hate, power, and also money. So when we're talking about software, when we're talking about digital economy, we're talking about how software is changing the way that people interact with each other. And some great examples of this new digital economy are that the largest car transportation company in the world owns no cars, which is Uber. The largest lodging company in the world owns no real estate, which is Airbnb. The largest online retailer in the world owns no stock, which is Alibaba. And the largest content network in the world produces no content, which is Facebook. All of these companies, they have something in common, is that they only exist because of software. So software is changing the way that we interact with other people. And it's very important for us to remember that software is made by people, for people. Every time we forget that, we don't deliver an optimal result of our work. And I also like to consider myself as a software craftsman. And the best definition that I have of a software craftsman is somebody who cares about what he or she does, because the software that we deliver into production can really change people's lives. And we know that we can make people miserable with the software that we do, because we know that sensation. We feel miserable when we use software that is not up to our expectations. And some years ago, when I was in a very hard moment in my career, I did like a hard decision. I decided in fact, I figured out that the only thing that I knew in my life was to code. Then I decided if I wanted to continue being a programmer, a software developer, I should be better doing it very well. That's why I decided to be a software craftsman, and that's why I care so much about what we do and how we deliver software into production, and how can we change people's lives, how can we improve their lives for the better. Okay, so we can make a choice, and if you're all here at that nice big conference such as DevOps Poland, if we're trying to learn and uncover better ways of trying to deliver better software into production, then I think we can all consider ourselves as software craftsmen, because we are changing the world for the better for ourselves, for our kids, for the people that we love, and for the people that we yet don't know. But we are doing something which we can consider like a legacy, a good thing for other people. And if we're talking about DevOps and microservices, I'm not going to dig into this subject, but if I got to choose just one simple thing to introduce to you about DevOps and microservices, I would like to say that all of the discussions around this subject, in fact, we're just trying to improve something that we call the feedback loop. And the feedback loop is something like essential for every human, because that's how we know that if we're doing the right thing right, and that's how we're able to improve the things that we're doing. In fact, if you think about the major revolutions or evolutions that we had in the past, like 40 years of the software development process, we all tried to improve the feedback loop. We will try to shorten the time that we had from doing something and getting the feedback of if you're doing something right or if you're doing the right thing. So think about in the past, we used to use test editors. We used to have to think a lot of time about what we were coding. Maybe we had to punch some cards, put it in our computer, and wait like some hours to check just if the code compiled. So just to check if the syntax was right. So then we created, now we have these online modern IDEs that while we're typing, they're able to check if the syntax is right. Maybe some of them can even compile your code to check if the semantics is right for us. Then we created automated tests. We didn't have to wait like a week to check if the testers, if our code was behaving properly. We could just run an automated build. Then we could check the test if we didn't break anything in another part of the code that somebody was coding. Then we created continuous integration to solve one of the hardest problems that we have in software development, which is to check if I'm not screwing what other people are doing. We try to solve this problem by doing that more often. If you get to check, the feedback loop is basically, we try to shorten the lead time that we have between doing something and checking if you're doing the right thing right. So the shorter the feedback loop, the better is the general result of what we're doing, no matter what activity we are doing. And the software can be different. And if I want to give you just one technical term about DevOps and microservices, I'll have to tell you that the most important measure for me in any DevOps and microservices discussion is the batch size. And technically, the batch size is the amount of changes that you have into each one of your releases when you deliver that into production. So just to try to explain, I used to be an independent consultant before joining Red Hat, and I used to think, well, if the feedback loop is so important for us developers, why don't we improve that? Why don't we constantly try to reduce our batch size? And I asked this question, what prevents you from delivering software faster into production? And the number one excuse that I always received was that we don't release software faster into production because when we release software, we have a lot of bugs. These bugs disrupt the users. That's why we can't release it faster, because we need more time for testing. We need more time for testing to solve the bugs that we are delivering to production. But people usually don't realize that the more time you have for testing, the more time you have for coding. So if you're just you're releasing software every month, if you have more time for testing, like 2 months, you have more bugs too, because you will be doing more coding. So testing time usually is not enough, and it's not a good excuse for you for not releasing software faster into production. So let's try to create a very simplistic correlation. I would like to say to you that what causes bugs into production usually are changes. And changes in 3 different aspects of our environment, of our software development process, which are basically, we have changes in the code, we have changes in the data, and we have changes in the environment that our code runs. So let's try to simplify that even more. I'll tell you that what causes bugs into production are basically changes in code. So if you establish this correlation, the more changes in code that you have into each one of your releases, the more bugs that you have into production. So the anti-economical way, the human way of solving this problem is we need more time, and more time means more time for coding, and the more changes that we have in the code, the more bugs we have into production. So the economical way of trying to solve this is to reduce the amount of changes that we have into each one of our releases, so we'll have fewer bugs into production. Maybe we need to improve our batch size, we need to reduce our batch size until like an ideal size of a single commit. So perhaps if I have a fully automated software deployment pipeline, if I get the chance to give like 1 commit, 1 deployment into production, if I have any bug into production, where's the problem? Maybe it's in that on that single commit with just 15 lines of code, so it's easy for me to spot where the bug is, where the problem is. In fact, people with sufficiently mature software deployment pipelines, which are able to do like 1 single commit, 1 deployment, it's much easier for them to not have a rollback strategy. It's much easier for them to just, well, if we deploy the bug into production, it's much easier for you to analyze the code that we just deployed, because that's like a few dozen lines. We just analyze the code, find the bug, fix that, and deliver that into production very quickly. That's the modern way. That's the ideal way of maybe trying to reduce our batch size and deliver better software into production. But even if we try to get into this ideal point, and I'm not saying that everybody needs to get to 1 commit, 1 deployment. Maybe for some industries like banking, we have this very interesting case where we have a Swiss bank, which we were able to reduce their batch size to 1 week. And 1 week, maybe for a bank, it's awesome, because I don't see people like checking everything with all of the bank regulations and delivering software faster than once a week. So maybe 1 week can be good for you. It really depends on your particular use case. But if we're trying to aim for the 1 commit, 1 deployment, even if you try, we as developers, to reduce our batch size until this ideal side, there's something called the maintenance window, which is the specific time frame of the week or the month or the year that the ops guys allow us to release our software into production. So the deployments usually are only allowed to be done when we have the maintenance window, and because we're not allowed to disrupt user into productions. And usually the ops guys too, they establish a maintenance window for us because we break things into production. So we have to break this vicious cycle. We need to be able to release software faster than the maintenance window allows. So we don't want to be releasing software like every single week at Saturday, 3 a.m. We want to be able to deploy software every day, every hour, in the middle of the day, without disrupting user into productions. If we want to break the maintenance window, we need something which is called zero-downtime. We need zero-downtime deployments. And for us to achieve zero-downtime deployments, we have 1 requirement, which is we need at least blue-green deployments. And blue-green deployments, I'll try to explain to you very quickly. Blue-green deployments in a traditional architecture, you have your clients issuing requests directly to your deployment, which are called the blue deployments. If you want a blue-green deployment, you need to add another component to your architecture, which is a proxy, which can be a load balancer or a reverse proxy. It doesn't matter. It's just some entity which is receiving requests and forwarding it to a backend. So if I have a proxy in the front of my architecture, now I can create 2 separate environments, 2 equal environments. Each one of them is capable of handling 100% of my production requests at a given moment. So I have a blue and a green deployment. And if I want to create a blue-green deployment with zero downtime, then maybe I can ask my proxy to stop issuing production requests to my green deployment. I can stop the servers. I can copy the new artifacts. I can start the server again. I can wait for it for warm up. If it's using Java, for example, maybe I want to issue some fake requests just to warm up the JVM so it can be fast enough. And when it's fast enough, maybe I can ask the proxy, well, you can handle the request now to the green deployment because now it has the new version. And this way of this method of deploying with blue-green deployments is not only allow us to have zero downtime deployments, but also allow us to have safer deployments. Because if anything went wrong with the green deployment, if we decided, well, now we're having too many errors on the green deployment, maybe we can just get to the proxy and just route the request back to the blue deployment because it still has the old version. So it's a very easy strategy for you to roll back your version because you always have like the new version and the old version running simultaneously, okay? But if the green deployment went well, then we can ask the proxy to stop issuing requests to the blue deployment and start issuing requests to the green deployment, and we can do the same with the blue. We stop the servers, we copy the new artifacts, we start the servers, we issue some fake requests, we wait for it to warm up. When everything's okay, we ask the proxy, well, now maybe you can handle you can issue requests to both backends because both have the new version and working well. You can even load balance the request for now, but that's just an option. Usually you just use blue-green deployments for a failover strategy. But it doesn't matter how hard is your code or the structure of your code. When you're deploying blue-green deployments to production, if you're thinking about code, code is very easy. Because the hard part is the state. State is always harder than code, and usually in some applications, it is very hard. And when we're talking about state, usually you have two different kinds of state in your applications. You have ephemeral state, which is usually the state that you store in your HTTP sessions, and you also have persistent state, which is usually stored in a relational database. I know some people think about NoSQL databases and everything else. I think they're a great solution. But if we're talking about enterprise software, and 90% of the software developers in the world that develop enterprise software, so maybe we should be thinking about relational databases. Many of the techniques that I'm going to present for you today, they are not specific to relational databases, so you can modify the concepts to be applying into any kind of persistent state later, okay? So the number one question that I always have, well, but if I have a legacy, old monolithic database and I want to be able to create zero downtime deployments with my relational database, how do I deal with that? Because usually my application can't handle. I have a new schema of my application, and the old version of my application can't manipulate the data with the new version, or the opposite. So the answer for you, if you want to be able to do this zero downtime thing with relational database, first step, you need to automate everything. You're not allowed to be applying your SQL statements anymore, your alter tables or update statements. You're not allowed to do that manually. You're not allowed to mail the script to the DBA to apply that when you release a new version. You're not allowed to create a Jira issue to be applying the statements anymore. You need to automate everything. So these tools, these database migration tools, they need to be part of your software development process. They need to be applied either on the startup of your application, which is one possible approach, or you need to apply that into a specific step of your software deployment pipeline, which is particularly my preferred option. So two of the most popular tools that we have in the Java world are Flyway and Liquibase. They are not specific to the Java world, they just happen to be implemented in Java, but you can use them into any specific technology. I just have a particular choice for Flyway because I helped it to patch and deploy the SQL Droid, which is a JDBC driver for Android, and Flyway works with Android because of this JDBC driver. So in the last project that I was working on, we were using Flyway to automate the migrations, both in our backend services and also in our Android application that was being deployed to the mobile phones. Okay? So if you want to achieve zero downtime migrations, first step, we need to ensure that we have back and forward compatible migrations into our deployments. And to achieve that, we need to split our big migrations into baby steps. So if we used to do like many steps into your SQL. If your SQL statement for database migrations used to have like 100 statements, maybe now you have just a single statement per deployment. Each one of your releases of software will have just a single statement of database migration. Just in case you're wondering what is a migration, migration is the technical term of the amount of SQL statements or code statements that you apply in your database to change your database schema from one version to the other, okay? This is the technical term, migration. Also, if you want zero-downtime migrations, you're not allowed anymore to have too many long locks. So if you have a table with like a billion columns, or sorry, a billion rows, and this update takes like 5 minutes, you're not allowed to do that anymore because lock time equals to downtime into production. So now you need to be able to shard these updates to avoid these long locks. And sharding is a very fancy term in the database world to just say that, well, now you need to split your update statements. If you're doing like, if you used to do like updating the whole table, now and it had a billion rows, now maybe you need to update your rows like 1 million at a time, so you can have a feasible downtime into production, a feasible lock time. Like, in how much downtime are you allowed to have? It really depends on your application, your business use case. That's why I always recommend you to rehearse a lot your migrations before applying them into the production database. So everything that we want to do well, we need to rehearse a lot. So if you used to issue the outer table, rename something to something else, maybe you need to split this thing into an add column first, to multiple update statement later, and then maybe you need to delete that later, right? So in the past 1.5 years and almost 2 years now, I talked to many different development teams and people worldwide trying to check how they were dealing with this kind of problem. And I was able to gather 4 different scenarios that teams worldwide are using. In the beginning, most of the teams that I was talking to were startup teams because they had very mature software deployment pipelines and they were using these strategies. But in the past year, I've been also seeing some enterprise companies being able to apply these techniques. So maybe you want to try that too. I was able to collect 4 main scenarios, which are add a column, rename a column, change the type and format of a column, and delete a column. Okay, and I'll pass through them very quickly. But if you want to see them and study them in detail, I have much more detail in my book. So first scenario, add a column. When you see steps 1, 2, 3, and 4, each one of these steps is going to be a different version that you're going to deploy into production. Then on the first version, you're going to issue an alter table add column. Second version, your code computes the read value and writes to the new column. And when I say compute, maybe it can be a default value, or if you can compute the value of the column using the value of other columns, you should be doing that. First step, you update the data using shards, and you need to be reminded that the third step can be multiple steps because maybe you need to shard your updates. And fourth step, your code reads and writes from the new column. And I have to tell you, between each one of these software releases, you will be opening your database CLI and you'll be issuing select statements just to check if your application is behaving properly, if your application is writing the right information into the new column. So this is not only the only way for you to be applying zero-downtime migration to production, is also the safest way for you to be releasing that. Because each one of these steps is non-destructive. You never lose any kind of information. They are always back and forward compatible. The new version is always compatible with the previous one. The previous version is always compatible with the new version of your database schema. So you don't have to be afraid to rely on a backup to restore the information on your database schema, because if you do this, the migrations this way, you're never going to lose any data. So that's why it's so safe. The second scenario is rename a column, and this is the most complicated one. First step, you add a column. Second step, your code reads from the old column and writes to both. Third step, you copy the data using small shards. Fourth step, your code reads from the new column and writes to both. Fifth step, your code reads and writes from the new column. And sixth steps, you delete the column later. I'm saying delete the column. You don't really delete the column. You just mark the column for deletion, because deleting a column is a destructive statement. You lose the data. So you just mark the column. So maybe like several releases later, maybe several weeks or even months later, you just create a Jira issue to your DBA. Well, in the next maintenance window, you check it if the data is not being used anymore, then you can safely delete the column, okay? So you always delete the column much later, never on the next subsequent release. Third scenario, change the type or format of a column, and you can see a pattern here. Yeah, that's exactly the same steps. It's a good thing. You're always able to be rehearsing the same steps. So change in type format column is the same thing as a rename column. And fourth scenario, delete a column. Don't. You never delete a column to production, because at the moment you do that, you lost all of the information. You don't delete the column. You just stop using the read value, but keep writing to the column, because maybe you're screwing something else, and your previous version still needs the data on the column, so you keep writing to that. And if everything is going well, then maybe you can stop writing to the column, and maybe later you can mark the column for deletion. That's the safe way for you to be deleting a column into production, right? What about my referential intelligent constraints? You don't have a miracle here. Sometimes I know it's if you think about that, you don't need these constraints for your application to work properly. They're just a safety net. So maybe at least on this moment, it should be safe for you to drop them and recreate them later when everything is working fine, right? That's what I had to tell you about zero-downtime migrations. And you might be wondering, why I'm talking about zero-downtime migrations if the topic here is microservices? Because in the past, when you had just a single monolith, the downtime of your system was the downtime of your monolith. But now if you have multiple microservices, multiple artifacts, the downtime of your system is the downtime of all your microservices multiplied. So the problem just increases, and you're not allowed to have downtime in your overall system just because you're updating the database schema of this microservice, just because multiple teams are updating their microservices multiple times per day. So you don't want to have this kind of downtime, because it will be very bad for your application. That's why you need zero-downtime migration. It is a requirement if you want to be able to be using microservice. You don't want to allow this kind of downtime in your overall system. Now let's dig into the microservices part. And Martin Fowler did a very good job trying to collect some characteristics of microservices. So he collected 9 characteristics of microservice architecture. And today I'm going to discuss with you the principle of decentralized data management, which means that each microservice must own its own database. That's the best practice, because we want to uncouple the queues of each one of those teams. And I don't want to tie my deployment cycle with the overall database deployment cycle, just because my version of the schema is not compatible with the version of the other team. So that's why each microservice must own its own database. And if the best practice for developing microservice is to start with a monolith and just start breaking some pieces of functionality into microservices, first you need to decide which piece of your database you must extract. And I would like to give you some tips about that, but unfortunately today, it is a very complicated subject, and I have to tell you that the answer goes through domain-driven design and properly domain modeling, properly business domain modeling, and properly creation of your bounded context in your application. So I can't help you with that today, because it really depends on your domain model. But if you've already chosen which piece of your database you decide to extract, then I can help you to make it work properly. Maybe I can help you to integrate that properly in your distributed system, okay? So if you want to extract your database, and each database must have, you must have one database per microservice, and you still have an old monolithic legacy relational database, the answer goes to that for some time, both monolith and microservice will need to access the same data, maybe in the same database or maybe in a separate database. And how do I do that? I'm pretty sure that splitting is not easy, but integrating that is also very, very complicated. Splitting you have to consider the business domain model. That's the complicated part. But integrating needs you need to consider the architecture and the technology. And that's what I want to show you today. But before I dig into the integration patterns, I have to give you a very quick explanation about consistency models. Again, it's an oversimplification. For us, the important ones for microservice databases are strong consistency and eventual consistency. In a strong consistency system, if you have multiple nodes in your system, all of the nodes in the system must agree before a client can read the new value. So if I say that now I equals to 5, all of the nodes in the system must agree, now I equals to 5 before any client can read the I equals to 5, okay? And that's usually the consistency model that you can achieve using transactions or distributed transactions. And eventual consistency, and I'm got to tell you, when we're talking about relational database, we only want the strong eventual consistency model, which is a very particular consistency model, which means that if I have multiple nodes in the system, I have to choose one, which is the canonical source of information, which kind of makes sense, because if I have a monolith and I decide to extract, well, I'm going to extract the customer information from the monolith. I'm going to create the customer microservice. The only endpoint in my system that is allowed to change the customer information is the customer microservice. So we have a canonical source of information where we're talking about at least on enterprise systems. So I decided that this is the canonical source of information, and the other nodes in the system, in a strong eventual consistency model, they can have outdated values, but all of the values are always correct. You don't have data conflicts, right? So if they decide that I want to update, now I equals to 5, and maybe the old value was 3, the other nodes can still have the old value 3, while this one has always the latest information. And then it propagates the changes to the other nodes. So some nodes can have the latest information, but some nodes of the system can have outdated information. How much time can you handle? Can you afford to have before updating all the nodes? Really depends on your business case. And you might think, oh, I don't want to do that. I'm not allowed to do that. Well, if you're thinking about distributed systems, you have to embrace eventual consistency for performance reasons. And if you think about that, most of the systems that we use these days, they are already eventual consistent. When you think about, if you have a web application, by the time you query your database, you manipulate the data, you build your HTML, and you give a reply to the user on the screen, by the time the user reads the screen, it's already outdated. So you're already handling with eventual consistency models. You're just not used to that. And you have to learn to live with this kind of consistency model. I also have to talk a bit about CRUD and CQRS. I'm pretty sure everybody have heard about CRUD, which is possibly the simplest possible architecture for us to be manipulating information, which means that all the operations, create, read, update, and delete operations, are all using the same domain model and the same data store. This is CRUD. So read and write operations, they use the same model in code and the same model in the database. What does it mean? It means that if I have a CRUD architecture, it means that I have a customer class in Java and I have a customer table and the other dependencies. I use the customer class and the customer table for all the read and write operations. This is CRUD. This is very simple. And in fact, I believe that for 90% of the architectures of the use case, this is the best possible architecture. But if we're talking about distributed systems, we need to understand properly what is CQRS. And I know that many people discuss the CQRS, but some people have some misconceptions about what is a CQRS architecture. And I'll try to give to you a very simple explanation. What is that? First, it stands for Command Query Responsibility Segregation, which is just a very fancy name for stating that in a CQRS architecture, you can have multiple domain models for read and write operation. What does that mean? And you all been using that for some time. You just didn't know that it had this name. For example, maybe I can create a customer class in Java for me to be issuing the write operations to the database. So I populate the customer object and I ask my OEM to be storing the customer information into the database. But for reading, maybe the customer has a lot of information, has email, has address, has transaction history, has the past addresses too. But if I want to generate a customer report and I just want the ID, the customer name, and the email addresses, maybe it's not a good idea for me to retrieve all the information that the customer object has into memory just to generate the report with these 3 fields. Maybe you want to create another class, a customer DTO class, which stands for a data transfer object. It is not an EJB 1.1 DTO. I'm just saying that this DTO is just a placeholder for information. It's a plain POJO, an anemic POJO. So maybe you can create a custom query in your database that just retrieve these 3 fields and you get a list or a stream of customer DDOs. So it's a better fit for you to generate your customer report. This is a CQRS architecture. Every time you have different classes for reading and writing, you are creating a CQRS architecture. But then if you think about CQRS architectures, you're not anymore constrained to have a single source of information on the persistence layer. You can change that. So a very interesting scenario for distributed systems and microservice architectures is the CQRS with separate data store. In fact, that's the pattern that we're most likely applying into our microservice architectures. With CQRS, with separate data stores, you can have different sets of tables in the database to be storing your write model and your read model. If you ever created a view in your database and created a query against your view to retrieve the results that you wanted to show the information into a different class, into a different object, you created a CQRS architecture. If you ever created a database materialized view to be able to aggregate the results to be creating a report, you already created a CQRS architecture, and you see the point. If you're creating a database materialized view, you're creating that for performance reasons. It's much faster for you to query the materialized view rather than all the times aggregating the results in memory using a query. So you're creating a CQRS data store for performance reasons. And in microservice architectures, you'll be creating CQRS architectures with separate data stores for performance reasons too, and for integration purposes. That's the main strategy that you will be applying, okay? And since we're talking about CQRS, I also have to talk a bit about event sourcing. Some people are advocating event sourcing as the solution for all of the integration problems in microservice architecture. And I have to tell you that take care. I work with a lot of different teams with event sourcing. And I have to tell them most of the teams, they do event sourcing wrong. So they take a long time to do it properly, and that's why they suffer so much. Because if you do event sourcing wrong, you suffer a lot. It's much worse than just creating a monolith and not using event sourcing at all. So be very careful if you're deciding to use event sourcing. But what is event sourcing? I'll give you the classic example of a bank account. You think about a bank account, and you have the amount of money that you have in a bank account. Maybe the canonical source of information on how much money you have in a bank account is not a column in a table in your database. You mean in a bank account, what do? You create multiple transactions, debit and credit transactions, one that sums and another one that subtracts the amount of money that you have in bank account. And if all of your bank accounts start with 0, if you add multiple debit and credit operations, if you want to know how much money you have right now, you just have to query all the operations that you have in your bank account, and you just sum and subtract all of them, and you have the current amount of your bank account. That's event sourcing. The source of the canonical source of information is not a single column in a table. It is provided by a stream of events, and in this case, it's a stream of debit and credit transactions, right? But you must be wondering, well, in a bank, it might work this way, but it doesn't perform that well, because the more transactions, the more debit and credit transactions that I have, and the more customers that I have, the more bank accounts that I have, the slower the system gets. So maybe you want to create another table with another column just for caching purposes, so they will have a cached amount of money that you have in your bank account, just for you to speed up your reads. So it will, well, if I want the right information, I write to the transaction table, but if I want the read information, I read from this cache. But you see, the canonical source information are the transactions, because the cache can be wrong. In fact, all of the banks, during the night, they just replay all of the transactions from the previous day, and just check that if the amount of money that you had in the auditing process is the same one that you have on the cache table. So you can check if anything goes wrong, then maybe you need to raise a manual issue. So some auditor will have to check the information that is reading on the transaction log. So that's how you handle. You have a CQRS and event sourcing. Event sourcing is the ability to write information as a stream event, and CQRS, you create another table with the cached value just for performance reasons. So that's CQRS with event sourcing, and they play very well in distributed systems, right? But it's not for everybody. So now that we know how this thing works, okay, I have to pass to give to you these different scenarios. I have 9 different scenarios for integration purposes. You can have shared tables, database view, materialized view, triggers, transactional code, ETL. data virtualization, event sourcing, and change data capture. And just to be try to explain a bit more why you should be using these integration techniques, because basically what I've seen in many different teams worldwide is that, well, we want to create microservices. We decide to split the customer information and create a customer microservice here. So they think, well, everything that we need to do to change in our old monolith is that, well, we have DAOs, we've done the code properly, so now we create a REST endpoint here. So our DAO, instead of be issuing queries to the database, now we'll issue an HTTP request and get information and transform the information into a Java object and manipulate the information on that, okay? They deploy that into production, they realize, oh my God, it doesn't scale. It's very slow. We need to fix that. Next step is, so it's too slow. Well, it's a performance problem, so we need to create a cache. So they create an internal cache in the monolith to be caching the information that you're querying. But then realize, well, internal cache is not enough. It's not performing well enough. We need an external cache. So they create an external cache service. They plug that at the monolith. So now you're caching all of the queries. For performance reason, they were, well, now it's performing well enough. But then we realized, well, but in the past, all of the reports that I had here in my old monolith, they were joining directly into the relational database with the customer table. But now I can't do that anymore. Now I have to fetch all of the information on the tables, and I have to query the customer information in memory because it's in a cache. Then I have to join all of this information to generate some kind of report. I have to do this join in memory. I have to get the objects and I have to get the result sets and join the information just to show the same information that I had before. That's too much work. Well, maybe why don't we create a CQRS table customer here, which is a replica of the customer information that I had in the customer microservice, and I apply some techniques for integrating this data. If I write here, to update my data in my CQRS data store, okay? So when you create a cached table or a replicated table in your old monolith with the customer information, you are creating a distributed CQRS data store. And some of the strategies that you can use for achieving that are this one. So let me explain very quickly to you these strategies. First strategy, you can use shared tables, which means both your microservice and your monolith or your other microservices are going to read and write from the same set of tables, which is the fastest data integration possible. You always have strong consistency because you're reading and writing in the same database with transactions. You have low cohesion and high coupling. In fact, you have such low cohesion and high coupling that I should consider this a hack. Don't do that, because in the teams I've seen doing that, shared tables are the perfect excuse for not changing anything anymore. Because if you want agility with microservices, if you have both this system and this system are reading and writing from the same database, I can't change the tables in the system here because the other systems is using the same information. And the opposite is true. This system can't change anything because this other system is changing the same information. And just for 2 endpoints. Imagine if we have multiple microservices, right? Because shared tables is a hack, and you should only be doing that if you know what you're doing that just quickly to deliver something to production, but you know in the next release you have to change this kind of integration. Next kind of integration technique is if you want to create this CQRS data store from the customer microservice, maybe you can create a view. And the view is the easiest one to implement, has the largest support from the MEMS because as of this year, even embedded database like A2 and SQLite, they have database views. You can have possible performance issues depending on the BMS you choose. You always have strong consistency because you have transactions, database transactions. One database must be reachable by the other, which means that you have different database servers. You need, at least on Oracle, you need to create a DB link between one and the other. And I know if I have any DBA here, it's going to curse me because, well, DB links are not supposed to be used for this. But I've seen teams using that, and I know that it works because in some integration scenarios, it really performed very well and it worked. And even though I don't recommend that, these database views on Oracle can be created as updatable depending on how you create the view. Next scenario, database materialized view, which I used myself in many integration techniques in the past. Offers much better performance than database views because instead of being an alias to your query, a database view is stored as a true table in your database, so you can optimize your database view too. as the same way as you would in a table. You can have strong or eventual consistency depending on how you update your materialized view. If you update on every commit, then it's strong consistency. If you update that on demand or on cron trigger, then it's eventual consistent. It really depends on your business use case. One database must be reachable by the other. Again, it means at least on Oracle a DB link, and at least on Oracle, again, it can be updatable. If you can use a DB link or not, really depends. You won't be able to use on-commit update because it doesn't perform very well. But depending on your how much delay can you afford on the staleness of your CQRS data store, you can use the database materialized view, because I've used that a couple of times and it works pretty well. You can also create a database trigger. Every time you write here, you write here. You also have strong consistency because you have transactions. But again, one database must be reachable by the other. And again, at least on Oracle, you need the database link. But database triggers, it doesn't perform, it doesn't scale. And I consider this a bad practice too, because what does it mean? It means that it only works for point-to-point integration because it has performance issues and scalability issues in terms of how many endpoints can you handle with that. Because if you have just customer microservice and monolith, every time I write here too, it works because I have a single endpoint. But maybe now I have 5 microservices, and all of them, they need the customer information. Then I need to create trigger code to when I write here, I have to write here, 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 here. It doesn't perform very well. In fact, it is also tightly coupled because, well, I can't change the data model there because I have to change the code here too, and the opposite is also true. So it should be considered a bad practice too, but I've seen some teams working. Depending on the size of your integration, it might work. You can also use transactional code, which is the same case of triggers. And when it says any code can be store procedure or distributed transactions, you always have strong consistency because you have transactions. Again, you have the same problems as transactional code. You can also use ETL. You have lots of available tools. You can use like Pentaho, you can use ClickView, you can use Dash Builder as your ETL tool. It requires an external trigger, which can be on demand or can be a cron trigger. You can aggregate from multiple data sources. It's always eventual consistent because by the time you read information, it's already outdated. And it's already in a read-only integration, right? I recommend this approach if the integration is not too big and if you already have people in your team which are used to be creating this kind of integration. If you're using to generate BI reports, you're already creating CQRS data stores. Maybe you can add another integration in your ETL tool to be creating another CQRS data store. So it really depends on your business use case. If it's not too big and you're already used to that, maybe you can use another one. You also have data virtualization, which is one of my favorites. Data virtualization basically means that you have your physical database and you create a virtual database on top of that, which can have a different view of your current information, right? Since you're always accessing the same physical tables, you have real-time access, you have transactions, so it's strong consistent. You can aggregate from multiple data sources, and it can be updatable. But the cool thing about virtual databases, this showed the basic architecture of TEID, which is an open source data virtualization platform. I just wanted to show you that you can have multiple data sources. You can create multiple virtual databases on top of your physical layer. And I think it's one of my favorites because it's also the safest one. Because one of the problems of microservices is that usually you split the wrong part of your monolith. And if you split it wrong, it's very hard for you to put information back. But if you're using a data virtualization platform, you just need to create a virtual database for your microservice, and the monolith is still using the old physical table. You just split that and start to play. If it doesn't go well, you can always discard the virtual database and start from zero. Right? So it's the safe, but if you did it right, then maybe later you can apply the changes that you apply on your virtual database to your physical tables, okay? Next strategy, event sourcing. As I described before, the state of the data is stream of events. It's easiest auditing. It's eventually consistent because you use a synchronous message. You use a message broker for distributed the messages. And again, I recommend event sourcing if your domain model is already modeled as event sourcing. I don't recommend you take a legacy code, a code that is already performing to production, and change the architecture that you have on the information to behave as event sourcing. I think that's a non-working approach. It works very well if you have to restructure everything, or if you're performing a greenfield project. But or else, I don't recommend event sourcing because as I said, event source is very hard to do that properly. The last one is change data capture. They change data capture. Again, what do? I can call it poor man's event sourcing, because CDC tools, they plug into your database and they read your database transaction log. So for each one of your alter tables, insert, update, and delete statements that you issue against the database, the CDC tool will capture that, will stream that through a stream for a message broker, and the other endpoints will be able to consume this information and manipulate that and write to the CQRS data store that you have in your distributed system. So CDC is my favorite one because you don't depend on any technology. You just depend on your database because the tool plugs directly into the database, and you can read from the message broker and implement that into any technology that you wish to, right? And it's highly scalable and everything else. And I want to show a very cool demo. I know I'm over time, but it will be a very quick demo, I promise. I'll show Debezium is a CDC tool which is sponsored by Red Hat, currently integrates with MySQL, Postgre, MongoDB, Oracle. It's almost final, and the next one is probably SQL Server, just in case you want to check. If you want to check another CDC tool, if you ever used Oracle Golden Gate, which is a very expensive solution, is also kind of a CDC tool for replication. So how does Debezium work? So my very quick demo is this one. If you get to check here, I have a Zookeeper instance running, which stores the information from my Kafka bus. I have Kafka running, which is a very dear message broker these days. Everybody loves Kafka, particularly because it's high performant, it's ordered, and it's persistent. All of the clients, they always receive the message in the same order. And if you think about that, it's very important to be ordered if you're thinking about replicating information, because the order that you apply the transactions modify the state of the data, right? So you can have problems if it's not ordered. And it's persistent, so it never loses a message. That's why Kafka is so dear these days. I also here have a MySQL server running. And here I have a MySQL client. So I get to select from customer. So I have 4 rows here, and I want to update. So here I have Debezium running too. And here I have a Kafka watcher, which is just an application that watches the messages that are being propagated on a Kafka bus. And what I want to show you is that I'll get here. Let's update one row in my database. So I updated that. If I select again, you can see now the name is El-Mahi. And if I get here, well, Debezium propagated a message on the Kafka bus. Let's see what the message has. So if I show you the message formatted here, you can see that Debezium broadcast the content, the schema of the data before the statement and after the statement too. So if that was an alter table statement, it's very useful for you. But since it was an update statement, you can see that Debezium broadcast the payload as it was before. You can check that it was N. And after the statement, it is El-Mahi. And you have some internal information here. And the operation is an update statement. You can see if you have received this JSON information, it's very easy for you to manipulate the information and create your own CQRS data store. Maybe the customer table is very big and you don't want to replicate all of the data. You just replicate the data that makes sense to your microservice or your monolith. Right? So I think you can all think about it's very easy for us to be manipulating this JSON message and work on that. So another question that usually people have, which I won't show because we were over time, is that what happens if Debezium goes down, if the Debezium service stops? Well, the point is Debezium stores on the Zookeeper instance in which point of the transaction log it has stopped. So you can safely stop the Debezium, and you can keep transactions rolling on your database. When Debezium goes up again, it knows in which point of the transaction log it has stopped, and it starts to broadcast new messages from the point it has stopped. So it's very safe. You don't have to worry about losing any kind of transactions because Debezium handles that. And of course, you have some granularity. You can choose which tables, which schemas you want to listen for changes, and everything else, right? So that's what I wanted to show to you today. That's the Debezium demo that I want to show today. I hope that the content was helpful to you. I would love your feedback if you have any other kind of different strategy, or if you are using any kind of different strategies. I would love your feedback. The best way to reach me out is on my Twitter at Yanaga, or just in case in my email, yanaga@redhat.com. And thank you very much.